The topic for this video is one-to-one functions and inverse functions. So I have two sets here. I have the set A and the set B. And let's remember what a function is. A function takes one set, and I'm going to let that set be A, and sends it to set B. And for every element in set A, which we call set A the domain, we send it to exactly one element in set B. And the set B is called the range. So for example, I could map 1 to 5, 2 to 7, and 3 to 8. This would be a function, f, this mapping. We can write this function like this. F of 1 is equal to 5, f of 2 is equal to 7, and f of 3 is equal to 8. And another thing we can do is we can write this as ordered points, or ordered pairs. So 1, 5, 2, 7, and 3, 8. Now something we can't do for a function is we can't send an element A, like in A, like the number 1, we can't send it to more than one element. So we can't send this number 1 to like 5 and 7. So every element in set A is only mapped to one element in set B. So that wouldn't be a function if 1 was sent to 5 and 7. But we could do something like this. We could send 2 to the number 5. That would be a function. See, every element in A is being sent to exactly one element in B, but we can repeat elements in set B. So 1 can go to 5 and 2 can go to 5. But if we have a function where every element in A is sent to one element in B, and we don't repeat elements in B, so like this function here where each element, you see this 1 is going to 5, 2 is going to 7, and 3 is going to 8. We're not sending any of these numbers to the same number in set B. This is called a one-to-one function. Let's write this definition down. So a one-to-one function, and you'll see me abbreviate this as 1-1 like that, so as one-to-one. So a one-to-one function is a function where for any x1 and x2 in the domain f of x1 is not equal to f of x2. So just like this one, we had 1, 2, and 3 in the domain. When we applied f, we sent 1 to 5, 2 to 7, and 3 to 8. So we never repeated any of the, what we call the y values. So that's what a one-to-one function is. Now, you might be given pictures like this on your homework where you're asked to figure out if it's a one-to-one function. Something else they might do is give you a set of ordered pairs and ask you if this is a one-to-one function. So notice that we can write a picture as a set of ordered pairs. Let's look at some examples of ordered pairs. So here's our first example. Does the set below represent a one-to-one function? And here's the set. 1, 1, 2, 4, 6, 8. So the answer is yes, because this number's in the domain, 1, 2, and 6, they're all in the domain, and you could draw a picture if you wanted to. You could put 1, 2, and 6 like this, and then make your range over here. You have 1, 4, and 8, and you can see that 1 is being sent to 1, 2 is being sent to 4, and 6 is being sent to 8. So with all of these arrows, I don't have 2 arrows going to the same element in the range. Another way you can see this without even drawing a picture is just to look and see if any of the y values are repeated. you can see that all of these y values are different. So since they're different, this is a one-to-one function. Let's do another example. So I'm going to actually just erase right here. I'm going to put some new points here. So does the set below represent a one-to-one function? So we have 1, 3, 2, 7, 3, 8, and 4, 3. So what you're going to do is you're just going to look and see if any of the y values are repeated. Notice that I have a 3 here and I have a 3 here. So this is not a one-to-one function. Again, you can draw a picture if you like. We have 1, 2, 3, 4. Those are the numbers in the domain. And 3, 7, 8, and 3, those are the numbers in the range. And you can make a mapping. You can say 1 goes to 3, but also 4 goes to 3. And you can see I have 2 arrows going to the same number. I'm repeating this number here, so it's not a one-to-one function. Okay, so most functions that we're going to see in this class are going to have infinite numbers in the domain. Like the domain will be all real numbers, and we'll be given an equation for a function. And what we want to figure out is if the function is one-to-one. So it's going to be, the idea is the same. You don't want any values for your domain. When you plug them in, you get a repeated y value. So let's look at an example. Suppose the function g is given by g of x is equal to x squared. And I've actually graphed this function right here for you. Is the function g one-to-one? Well, again, the idea is, do we have a number in the domain? Notice that the domain of this function is all real numbers, because I don't have any fractions or square roots in the equation for this function. So the domain, I can put whatever I want into this equation here. And how we figure out what things are being mapped to, like if we plug in 0, g of 0 is 0 squared, which is 0. And that's how I got this point 0, 0 here, just as a brief review. Of course, we have the point 1, 1. We have the point negative 1, 1, the point 2, 4, and the point negative 2, 4. Now, the definition of something being one-to-one says that for any two values that we plug in to g, we don't get a repeated value for the y value. So if I plug in 1 into this function, I get 1, which I have that point right here. At the same time, if I plug in negative 1, I get the value 1, because negative 1 squared is 1. And you can see I have that point here. Here I have two different x values going to the same y value. And because we're being sent to the same y value, this is not a one-to-one function. So the answer is no. Another way you can tell this is just by looking at the graph. We have something called the horizontal line test. Now you might remember the vertical line test, and the vertical line test told you if you have a function. So the vertical line test was, if I draw a vertical line and I intersect the graph, wherever I intersect the graph, I'm only going to intersect the graph one time. And that would tell you you have a function. Here, the horizontal line test says, if you draw a horizontal line and intersect the graph in more than one point, then it's not a one-to-one function. Let's write that down. Put it right here. So the horizontal line test it says, if every horizontal line intersects the graph of f at most one time, or at most 1 point, then f is 1 to 1. So for this particular example, you can see that, although this line's not very straight, if you make a straight horizontal line, we're going to intersect this graph at more than 1 point. So it's not 1 to 1. This is actually a easier way to tell if something is a 1 to 1 function. This particular example, g of x is equal to x squared, it was pretty easy to figure out a point that's sent to the same, so like two x values being sent to the same y value. But sometimes it might be difficult, so it's better to graph it and just see if it passes the horizontal line test. Let's look at another example. Here I have g of x is equal to x cubed. Is this function 1 to 1? Well, let's look at the graph over here. Notice that if I draw a horizontal line anywhere, particularly around these areas, I'm only going to intersect that graph one time. You might think maybe right around here, maybe in this area here, it might look a little confusing because it almost looks like a straight line right here. But if you zoomed in enough, like if you graph this on a graphing calculator, if you zoomed in enough, what you're going to get is you're going to see that this line right here is actually not a straight line. This function is always increasing. And because of that, if you draw a horizontal line, you're only going to intersect the graph one time. So the answer is yes here. And you can say because it passes the horizontal line test, but you could also plug in some points. You can see that anytime I plug in an x value, any x value you choose, you're going to be sent to the cubed of it, and you're never going to repeat a y value. The only time you're going to repeat is if this was an even number. So if you had a 2, a 4, a 6, because anytime you plug in a negative, when you raise a negative to an even power, it becomes a positive. So wherever you had a positive, like if you plugged in a positive 2, and this was x to the 4th, you'd get 2 to the 4th. But if you plug in a negative 2, you'd also get negative 2 to the 4th, which is 2 to the 4th. So even powers would not be one-to-one functions, but odd powers are one-to-one functions. Oops. Okay, let's move on to another example. Here I have a function g of x. Originally, let me erase this for just a second. Originally, we were given this function here, x times x minus 3 squared. And here's the graph of that function. I also, right underneath it, I put the equation FOILed out. So if I just multiplied all of this out, here's the equation. So if I gave you something like this on a homework or test or something, and I asked you, is this function 1 to 1? So is g 1 to 1? Well, this one might be harder to figure out because you have odd powers and even powers here. But if you look at the graph, you can tell right off that this is not a one-to-one function, because if I draw a horizontal line like right here, I'm going to intersect 3 times. So the answer is no. But also in this factored form, notice that I can find an example of an x value that actually 2 x values that are sent to the same y value. Because if I set this equal to 0, well, you'll see that I get x is equal to 0, and also x is equal to 3. So in other words, when I plug in 0 into this function, I'm going to get 0. And at the same time, if I plug in 3 into this function, I also get 0. So here you can see I have 2 x values being sent to the same y value. Here's a picture of a rational function. G of x is equal to 1 over x. Remember that a rational function is a polynomial over a polynomial. Let's look at the graph. If we draw horizontal lines anywhere, you can see that we're just going to hit this graph one time. And this area, again, this might be a little bit confusing in this spot here, but if you zoom in, remember that this is an asymptote, this line right here, y is equal to 0. So this is going to be increasing forever, but getting really close to 0. And this one is decreasing forever, but getting really close to 0. So if you were to zoom in and draw horizontal lines, you still only hit the graph one time. So this function is one-to-one. And again, we can plug in things into G and we'll see that we won't repeat Y values, because if you plug in something like a 1, you get 1 over 1. If you plug in 2, you get 1 over 2. There's no other way to get 1 over 2. You plug in a -2 here, you get 1 over -2, which is not the same thing. So you're not going to be able to find repeated Y values. Sometimes in your homework, you'll be given just a picture and no equation for G. And I'll just ask you, is this function one-to-one? Well, again, all you have to do is just try the horizontal line test. You can see for this function, I'm intersecting more than one time. So this function is not one-to-one. Here's a picture of a horizontal line. So this is actually an interesting case. So if you have a function, f of x is equal to ax plus b. So something like f of x is equal to 3x plus 2. As long as this number here is not equal to 0, that means your line is going to have a slope. So it's going to look like this or this. And if that's the case, then the function is one-to-one, because you can see if you pass a horizontal line through it, it's only going to hit it once. But here I have a horizontal line. So if I pass a horizontal line through it, I'm going to hit the horizontal line at every single point. So this is not one-to-one. So a function that's a line that has a slope of 0 is not one-to-one. You might also wonder about if something like x is equal to 3, would that be a one-to-one function? And the answer is no. Although x is equal to 3 is a vertical line, this is not a function, because if we did the vertical line test, it wouldn't pass. So because this is not a function, it can't be a one-to-one function. Our next topic is inverse functions. Now, what is an inverse function? So here I gave you 3 points, 1, 2, 4, 3, and 6, 8. And remember that when you see some points, you want to think of functions. So we have some function that sends 1 to 2, 4 to 3, and 6 to 8. So let me write that down here. F of 1 is equal to 2, f of 4 is equal to 3, and f of 6 is equal to 8. And this is not just any function, this is a one-to-one function, because none of the y values are repeated. When you have a one-to-one function, you can have something called an inverse function. In fact, you always have an inverse function for a one-to-one function. What an inverse function is, it's going backwards. So an inverse function sends 2 to 1. We call this f inverse, like this, and 3 back to 4, and 8 back to 6. So it's like undoing what we've done. So 2 will go to 1, 3 goes to 4, and 8 goes to 6. So it's like reading the points backwards. So to do a inverse function, well, we'll go 1 to 2 and go back to 1. 4 goes to 3 and goes back to 4. So it's just reversing this relationship. Let's write the definition down here. So an inverse function. So to have an inverse function, you have to have a one-to-one function. So suppose f is a one-to-one function. Then that means every x in the domain, I'm going to just use D for domain, corresponds to 1y in the range. And I'm going to use R for range. And for every y in the range, you could think of there being only one x that corresponds to it. So there's one x in the domain, to that y. The correspondence of the range of f back to the domain is the inverse function of f, and we use the symbol f raised to the -1. We're going to talk more about that symbol in just a minute. Let me just look at this definition again. I know it's kind of big, so let me zoom out a little bit. Maybe we can get it all in one page here. Okay, so you're going to have a one-to-one function. That's the only time you're going to have a inverse function. So if you have a one-to-one function, then every x value in your domain goes to one y value in your range. And you could also think of this backwards. Since we have one x going to one y, then we have one y going to one x. So that's what I have here. And for every y in R, there's one x and D corresponding to that y. Then this correspondence of thinking about the y's going to the x's, that is a function. And that function is called the inverse function. And that is what we're going to write as f inverse here.